A warm welcome again, everyone. Whether it's morning, afternoon, or evening, whichever part of the world you are, we are glad you are here for our dynamic talks. Thank you for joining us from around the world. Before we begin, let me take a moment to introduce myself. My name is Rohit, and I spearhead talent, client, and brand marketing for Grid Dynamics in the India region. I'll be your moderator for today's session. Welcome to Dynamic Talks by Grid Dynamics, a platform designed to foster innovation, share knowledge, and connect with the brightest minds in technology globally. We are thrilled to have you here today. I appreciate your presence as we embark on this journey of learning and discovery. In short, Dynamic Talks embody our mission to lead, learn, and connect with our clients, our community, and future colleagues. Even if you're not actively job seeking, we hope these discussions spark curiosity about opportunities to join a team driving meaningful technological change. Please allow me to briefly share what Grid Dynamics stands for. We are a NASDAQ listed technology consulting leader trusted by Fortune 1000 companies across finance, retail, and tech industries since 2006. Headquartered in California, we operate globally with over 4,600 engineers in 18 plus countries. As a NASDAQ listed public technology services company, we are at the forefront of big data, data science, machine learning and AI, scalable omnichannel services, DevOps, and cloud enablement. We are also proud to be part of the S&P 600 index, a testament to our growth and innovation. Now let's turn on towards today's agenda. Please join me in welcoming our esteemed speaker, Karthik, software architect at Grid Dynamics. Karthik Aitipamula, a seasoned technology leader with over 13 years of experience in cloud computing, AI, and digital transformation. He currently works as a software architect within the CTO organization, where he balances architecture with hands-on coding, driving innovation in cloud-native, AI-driven, and scalable solutions. His expertise spans end-to-end solution design, transitioning legacy systems to modern cloud architectures, and implementing AI and automation to optimize development. He has played a crucial role in leading teams, guiding organizations through technology modernization, and ensuring best practices in security, DevOps, and performance optimization. Beyond his technical leadership, he is passionate about mentoring, pre-sales strategy, and helping teams build future-ready applications. Get ready for an exciting session as Karthik shares his knowledge and practical insights. Let's give him a warm welcome. Please feel free to submit questions via the Zoom chat during the talk. We'll address them after the presentation. Alternatively, you'll get to unmute your microphone to ask it live towards the end of the session. Without any further ado, Karthik, the virtual floor is all yours.
Thank you, Rohit, for the warm introduction. Let me share my screen. Hope you are able to see my screen.
Yes,
right?
Karthik.
Thank you. Good morning, good afternoon, and good evening, everyone. It's great to see so many of you here today. My name is Karthik, and I am a software architect at Grid Dynamics. From architecting enterprise solutions to hands-on coding, my journey has been about blending technology, AI, and cloud innovation to solve real-world problem challenges. Before we dive in, let me ask you something. Have you ever felt like integrating AI in your Java applications was overly complicated or fragmented? If that sounds familiar, you are in a right place. Today, we will explore the modern structured out approach, Retrieval-Augmented Generation, with Spring AI, the transforms way Java developers can build powerful enterprise-grade AI apps. We will also look how frameworks and protocols like Spring AI, MCP, together with Vertex AI on Google Cloud, can simplify your journey dramatically. By the end of this session, you will clearly understand how RAG enables LLMs to deliver accurate, context-rich responses by connecting them directly to your data. You will also see how Spring AI makes it straightforward to integrate advanced AI capabilities into your existing Java system. And also how MCP can connect to different data sources and how we can deploy our application on scalable environment with Vertex AI on Google Cloud. My goal today is simple: to show you exactly how you can start creating robust, scalable, AI-powered Java application without friction you might have been used to. So let's jump right into it. To set the stage, many Java developers looking to integrate AI see the landscape dominated with Python, which can lead to a misconception that Java developers need to learn Python to fully leverage AI. While picking Python can be beneficial, it's not the only way path forward. We now have an option that can let you stay within the Java ecosystem. Additionally, team struggles with ensuring that models remain accurate, especially in production hallucinations, where model fabricates answers and can erode trust. Keeping models up to date and reliable in a fast-moving environment is a major concern for enterprise application. The good news is that the recent Java frameworks and protocols aim to solve these issues. Spring AI powerfully AI capabilities directly into a Java ecosystem. No need to abandon your Java skills or existing toolkit or deployment pipeline. With the right architecture, you can build an advanced AI future like RAG without becoming dependent on Python libraries. We will explore how combining RAG with Spring AI, MCP, and Vertex AI addresses these common points for retrieving real-time data, using MCP to call different servers to leverage the hosted models on GCP. This holistic approach helps ensure accuracy, minimize hallucinations, and maintain familiar Spring Boot-friendly deployment experience. Let me talk about some of the challenges and opportunities for the Java developers. In today's world, we all know that Java developers are already expert in building a reliable and large-scale applications. The real challenge is bridging the gap between existing ecosystem and specialized AI tooling that have traditionally revolved around Python or other platforms. These difficulties often manifest as a soil approaches. Some scripts on Python, some are of microservice-based Java applications, and complexity around ensuring model reliability and streamlined deployments. This session introduces a more unified strategy, combining Retrieval-Augmented Generation, Spring AI with MCP, and also Vertex AI into a single cohesive workflow. With MCP, you can securely fetch data from different data sources, such as organizational search applications or on existing APIs, ensuring that AI receives a up-to-date context. Meanwhile, Vertex AI can provide a powerful models like those from Google, so you don't have to worry about hosting them or managing them yourself. So let's do a quick poll to see your current involvement with an AI in Java. Here is a quick poll. We will have like 30 seconds. Yep. I see like 65% have been participated. Yeah, okay. I'm ending the poll in next 5 seconds. Yep. Yeah. Thank you for your responses. It's great to see where everyone is currently at. It looks like many of you have just started with some POCs, and most of you have no experience. Okay, are just starting a beginning to the journey. Okay, uh, thank you. Let me get you into the next slide. So now we have set the stage and discussed the key challenges and opportunities for Java developers. Let's outline the today's roadmap. First, we will talk about retrieval-augmented generations basics to see how it addresses the common problem around hallucinations and model accuracy. Next, we will dive into the Spring AI, a new framework that integrates LLM into a Spring Boot ecosystem. After that, we will talk about model context protocol for managing or retrieving data from different servers or different endpoints. We will then combine all these individual components to build a RAG application, which will be a step-by-step guide to building a application. And finally, we will discuss how we can deploy this application on Vertex AI or Google Cloud, which is scalable and also user-friendly. We will wrap up with Q&A. So if you have any questions comes into your mind, feel free to note from the end, for the end. Yep. Let me talk about Retrieval-Augmented Generation or RAG. So in simple terms, RAG is a technique where a large language model such as OpenAI, Cloud, Gemini, we have a lot of things, works in hand with external data sources or external knowledge base, which can help us to reduce hallucinations by grounding the answers on the real data, keeping answers up to date and domain specific. Rather than relying extensively on models' internal data or training data, it fetches the most relevant information from a specialized data store or search engine before generating the answer. To talk about the workflow, there are 4 basic steps. User submits the query, searches the prominent documents or data in vector database or any other specialized search service that passes the context to LLM. The model responses using this retrieved data, making its answer more accurate and up to date. This approach is critical for tackling hallucinations, where an AI might confidently give incorrect or outdated information. By grounding the model current domain-specific and contextual data, RAG ensures each response is backed by real, verifiable sources, which is particularly important in enterprise settings. Now let's look at some of the use cases which RAG truly shines. One is customer support, which automates the FAQs or troubleshooting by pulling data from latest knowledge bases or manuals. The second one is document Q&A. For industries like legal, healthcare, finance, RAG helps users quickly query large amount of data or documents, retrieving authoritative text snippets to support the answers. The other one is real-time chatbots. Chatbots can respond with context from up-to-date minute data, such as product inventories, recent announcements, or internal user guides, rather than relying on total models data. All these scenarios benefit from synergy between retrieval and generation. Now let us see a detailed architecture of the RAG and its different components. On this slide, we will see a retrieval-augmented generation architecture. It shows how user queries, document indexing, and how large language models interact to produce contextual and accurate responses. Let's walk through it by step. Starting on the left, a user submits a query. This could be any question or a prompt, such as what is our current refund policy? Explain the difference between some product X and product Y. Once the user sends this query, it travels to our system to find the most relevant data. That's where our next components comes in. On the right top, there is an indexing box. This is an offline or continuous process of ingesting data or preparing the documents for quick retrieval. We chunk large data or documents into smaller pieces, maybe paragraphs or sections, and convert these chunks into a numerical embedding. We store this embedding in vector database. This indexing step is crucial. Breaking content into chunks and embedding them, we can perform high effective semantic search later. Below of the indexing box, we see a vector database, which holds all the document embeddings. When the user query arrives, it too gets converted into embeddings, not shown explicitly in the diagram, but it is part of the pipeline. Using this vector representation, the system does embedding search against a vector database, finding the chunks most similar to the user query. This approach is more accurate than a simple keyword search because it captures semantic relationship. So it can retrieve the right information even if the parsing doesn't match perfectly. After the vector DB identifies the best match chunks, it sends back to retrieval relevant documents. These fragments contains the contextual information needed to answer the user query accurately. We see that arrow down the vector DB to the context extraction box. This means the system is effectively grabbing what it deems relevant to the question. In the content extraction step, we filter and refine information. Sometimes you may get extra noise in those chunks, maybe repeated or irrelevant text. However, we can apply custom logic to parse, clean, or combine the fragmented chunks. The final outcome of this stage is a refined context that we can directly push into the large language model with a user query. Next, we will see that refined context along with the user query flow into the LLM. This is where generation part of Retrieval-Augmented Generation happens. The LLM uses the retrieved context to ground its responses, reducing the likelihood of hallucinations and making it answer more accurate and domain specific. Finally, the LLM output is returned to the user, completing the loop. Because the model now had access to real, up-to-date information, and the answers should be both coherent and factual, assuming that the documents in the vector DB are relevant and correct. The core idea here is that we do not solely rely on the LLM's training data or knowledge. Instead, we harness the external, dynamically updated knowledge base, our vector DB and document store, to keep these responses fresh and correct and relevant to our context. This approach is critical in many real-world scenarios where data changes frequently or domain-specific accuracy is paramount. We will later see how frameworks like Spring AI can orchestrate these steps within a Java applications, and also how we can use MCP to manage the data retrieval and combine these tools to implement a RAG end-to-end application in our enterprise environment. Next, we will see how Spring AI and MCP seamlessly integrates this into a Spring Boot application, enabling Java developers to build RAG solution effectively. Now that we have covered the fundamentals of Retrieval-Augmented Generation, RAG, now let's turn our attention to a promising framework that makes RAG straightforward in Java ecosystem. It's called Spring AI, rapidly evolving project from Spring team. Think of a Spring AI, an attempt to do for AI what Spring Boot did for web and microservice architecture. It provides a unified, opinionated framework that drastically lowers the barrier to entry for Java developers. According to the official Spring AI project page, it offers a consistent approach for interacting with AI services directly from Java code. Whether you are connecting to OpenAI, Gemini, Cloud, or any Google services, Spring AI hides the low-level design so that you can focus on business logic rather than manual API calls. Let me talk about some of the key features of Spring AI. LLM connectors. Built-in integrations with major AI providers are available, so you don't need to write all the boilerplate code for HTTP request or authentication. The second one is prompt templates and pipelines, a structured way to define prompts and orchestrate multiple steps, especially useful if you are doing a chain of thought or multi-prompt workflows. The other one is RAG compatibility. It's designed to coordinate retrieval steps like querying a vector DB before calling the LLM, tying it perfectly with our RAG approach, what we are trying to do now. Why does this matter so much for Java developers? For starters, it let us stay in the Spring Boot ecosystem and also in a comfort zone. Using the same dependency injection, auto configurations, and environmental-based properties which we already know. You don't need to jump to the Python if you're rather building AI features entirely in Java. Additionally, it's production-friendly environment. Through testing, meaning you can deploy these AI-driven features with the same confidence you have in your Spring Boot microservices. You can also scale in any environments on-prem, containers, or cloud, since it's just a Spring Boot application on its core. The Spring team is actually evolving its needs to enterprise needs. On top of that, staying in the Java ecosystem means you can integrate with model context protocol, which helps to manage model versioning or data retrieval from different sources. And you can tie everything into a Google Cloud or any other cloud. This creates a complete enterprise-ready stack. RAG for contextual accuracy, Spring AI for seamless integration, MCP for robust model data management, and Vertex AI for scalable hosting. So in short, Spring AI aims to simplify and accelerate AI adoption in Java world, much like what Spring Boot did for web and microservice development. It tackles the multiple friction points like connectors with the different LLMs, prompt engineering, retrieval orchestration, and production readiness. Up next, we will dive deeper into the model context protocol, fits alongside with Spring AI, and then we will look how we can put all together to build a RAG app that can scale on Vertex AI. Feel free to note any questions, and we will address them in Q&A session. Let's quickly discuss a common challenge team faces with LLMs. Typically, integrating LLMs into a enterprise workflows can get complex. You are dealing with multiple data sources, different APIs, and varying different integration models, each with its own proprietary method or standard. This often may be a costly or time-consuming to maintenance, especially when switching tools between different vendors. Here's where model context protocol steps in. MCP is an open standard protocol designed especially to simplify how application provide context to LLM. You can think MCP like a USB port for AI. Just like USB port lets you seamlessly connect various devices to your laptop or computer without worrying about the compatibility between them. MCP allows your AI models to integrate smoothly with different data sources and tools without rebuilding your systems each time. Let me talk about why MCP matters. There are three main reasons. It comes with a growing library of pre-built integrations. This means less manual coding and more productivity. The second, it provides a vendor flexibility. So you can switch between different LLMs provided easily, reducing the risk of lock-in with respect to LLMs. Third, it enforces best practices for data security and governance with your own infrastructure, critical for enterprise-ready applications. Ultimately, MCP simplifies your AI infrastructure, saving your development time, improving flexibility, and boosting overall security. In short, it seems the complexity of integrating context with AI workflows, so your team mostly focus on innovation rather than integration headaches. As we explore building RAG application, we will see how MCP make it simpler to keep track of connection with different data sources. Now let's me dive into how MCP architecture actually works, especially in the combination with our Spring AI application. On this diagram, we will see three different roles. One is host with the MCP client, servers that interactively communicating using MCP protocol. On the left-hand side, we will start with MCP host, which can be a IDE and a tools called Cloud Desktop, or importantly for us, Spring AI application. Imagine your Spring AI applications needs a real-time data or additional context to enrich LLM response. To achieve this, your Spring AI application leverages integrating with the MCP client, maintaining direct standardized connection to a different MCP servers. Moving on to the right, we have a MCP servers, modular and lightweight applications dedicated to specific tasks or connected to a specific data sources. One MCP server might connect to a web-based search capabilities. Another might connect to a securely server accessing local databases. Another can write or read local files directly. Each server follows MCP standardized interfaces, making it straightforward to integrate and extend. These MCP servers connect to either local data sources, such as files, databases, or internal services, or to the remote services accessible via APIs over the internet. In the context of Spring AI, this means you can seamlessly fetch documents from your local knowledge bases or perform securely API connections to enrich your prompts before feeding them into a large language models. For example, imagine your Spring-based real estate chatbot needs a current property listing. It its integrated MCP client to query the MCP search server, securely retrieving updated listing from a report or real estate database via API. This context is then neatly packed and returned directly into your Spring Boot application or Spring AI application pipeline, becoming the part of your prompt by the LLM to provide accurate and real-time responses. In short, combining MCP standardizes data access architecture with Spring AI's easy to use integration capabilities ensures that Java-based applications remain organized, secure, and scalable. You can extend functionality quickly, add or swap different data sources without any efforts, and ensures enterprise governance and maintainability across AI workflows. Now that we have seen the core concept behind RAG, Spring AI, and the role of MCP, let's walk through the steps of actually building RAG applications in Java. First, we will start with data ingestion and indexing. This typically means breaking your domain-specific documents like FAQs, product manuals, policy text into a smaller chunks of data and generating embedding for each chunk. We then store these embeddings into a vector database or specialized search engine that supports the vector search. This can be offline or periodic process in a crucial, fast, accurate, which will be helpful for fast, accurate retrieval in the later phase. Next, we will integrate these retrieval steps into our Spring AI setup. In a typical Spring Boot application, we will define a retrieval bean that queries the vector database when the user takes or when the user asks the question. With Spring AI providing a connectors, you can choose LLM providers like OpenAI, Cloud, Gemini. You can easily orchestrate a RAG pipeline. Spring AI shines here by offering a prompt template and pipelines. You can define a prompt template, for example, in the instance which is shown in the slide, like answer the user's questions using the provided context and the question, and automatically inject the retrieved text blocks and give input to this particular prompt. Spring AI handles standard Spring Boot conventions like dependency injection, configuration, logging, making it straightforward to manage in production. If you have a MCP setup, you can also define a model version and connect to a different data sources, ensuring consistency and well-documented environment. Finally, once LLM generates the response, it goes back to the user. Because the model is grounded by a retrieved context, the answer is far more reliable and up-to-date. You can also add a step to log or monitor these interactions, a best practice for AI application, especially if you need to track usage or fine-tune prompts for engineering later. At this point, you have a function RAG service Java running in Java. The next step, you will be deploying it either on the on-prem or in any cloud, like Vertex AI on GCP, where you can scale your LLM's request and manage everything under one umbrella. This integration approach of RAG, Spring AI with MCP gives a Java dev's powerful enterprise-ready toolbox for building accurate, context-driven applications. On this slide, we will see how various Spring AI components come together to build a retrieval-augmented pipeline. Let's walk through it step by step. Starting from the left, You have a user submitting the query, perhaps something like, what is the average home price in the downtown? The query goes directly into the query service, which is powered by Spring AI. This service handles the initial orchestration, including generating and embedding for user query and dispatching it to get the relevant data. On the right-hand side, you see a dotted box. We see a Pinecone as our vector database. Up top is the ingestion service, also built in the Spring AI. That service receives data from different sources, and these documents or data are like from different real estate property information and breaks down into a chunking and embeddings before storing it to the Pinecone. This can be an offline or continuous process that ensures we have a semantic searchable data for the real estate topics. When the query services retrieves the user request, it prompts the embedded search against the Pinecone database. Both the user query and the stored text are represented as embeddings. We can find the most relevant chunks on the real estate documents, even if user uses different wordings than what it is in the documents. These retrieved chunks can pass into a context extraction service. Here, Spring AI is used again to filter out the noise, refine the information, and prep it for prompt creation. Essentially, in this shape, we ensure that we have a right context to feed the data into the large language models. With Spring AI supports a prompt templates, the context extraction service builds a final prompt that combines the user intent, the relevant data which we fetch from vector database, and any other special instructions. This prompt is sent to the large language model, which could be OpenAI, Gemini, Vertex AI, etc., where the actual text generation happens. Finally, the LLM generates the responses and which flows back to the query service to the user. Because we have grounded the answer in the fetch domain-specific data, which is relevant to the context. It's far more accurate and relevant than if we solely relied on the large language models' internal training data. In short, Spring AI ties all these pieces together from ingestion and vector-based retrieval, creating the prompt, content refinement, and finally to the LLM inference. And then thanks to MCP, Model Context Protocol, so that we can track of data from different sources, making this entire flow traceable and maintainable, which is perfect for our enterprise AI application. Now we will see a small demo on RAG application POC, which we have built using Spring AI.
Welcome. Today, we're showcasing a proof of concept demonstrating how easily you can integrate powerful large language models with your Java applications using Spring AI. Our demo features a real estate property search assistant powered by intelligent AI responses. Let's see it in action. The user begins by typing a query into the chat. Notice, once submitted, our AI model evaluates this query in real time. Behind the scenes, the model is using context retrieved from external databases and web searches, reasoning and formulating an informative response. Now, the user asks a follow-up question. Again, the AI swiftly analyzes the context, filters relevant information, and delivers a precise, helpful answer. Our assistant seamlessly handles several queries, showcasing its capability to provide quick, context-aware responses. Before diving deeper, let's quickly highlight the dependencies essential to Spring AI integration in your POM file. These dependencies simplify setup, allowing us to leverage Spring AI's powerful features efficiently. Now, let's briefly explore the back-end code powering this interaction. First, the REST controller accepts user queries through a simple endpoint. The user's query is processed by the RAG service, returning a structured response back to the user. Next, let's look at our AI configuration. Here, we set up our Pinecone client to fetch contextual data using embeddings, enabling efficient semantic searches. We also configure our chat client and embedding models through Spring AI, seamlessly integrating advanced AI capabilities. Finally, our core service class combines context from both vector stores and real-time web searches. It dynamically builds a prompt, interacts with the large language model to generate structured JSON responses, ensuring relevant and context-rich information is delivered every time. With Spring AI, integrating advanced LLM capabilities into your Java applications is intuitive, efficient, and powerful. Thank you for watching.
Thank you. Let's get into the next slide. Now we have seen how we have built a RAG application using Spring AI and integrated with MCP. Let's talk about deploying and scaling. Two critical like important steps for production graded AI systems. Here, Vertex AI on Google Cloud can play a pivotal role. Vertex AI is fully managed machine learning platform that simplifies everything from model training and hosting to advanced feature like hyperparameter tuning and batch predictions. But for our RAG scenario, the key benefit is that we can deploy and scale our applications seamlessly. Whether you are hosting LLM directly on Vertex AI, fine-tuning a pre-trained model, or just wanting robust auto-scaling to your microservices, Vertex AI provides these capabilities in one roof. In practice, we will have few deployment options. One is containerization your Spring AI applications using Docker and push it to a Google container registry and then deploy it onto the Cloud Run or GKE with a built-in auto-scaling. If you prefer managed model endpoints, you can host or fine-tune your LLMs in Vertex AI endpoints, like letting Google handles infrastructures like GCP or specialized hardware. Integrating your pipeline so that your applications calls Vertex AI model inference APIs, whenever you need a generation. This way, your Spring AI app can remain lightweight while you offload heavy model computation to Vertex AI. Huge advantage here is the ability to auto-scale based upon the traffic. So if you experience a peak load during the business hours, Vertex AI or Cloud Run can spin up additional instances during the off hours. It can scale down to save costs. Finally, we will pay some of our best practices. We can monitor our usage and performance via cloud monitoring to ensure that we don't overpay. And we ensure that all the endpoints are properly authenticated or encrypted. Now, let's have our second poll. Hope you are able to see a second poll. Yeah, I think I am getting the responses. I will wait for next 5 to 10 seconds and I will end the poll. I see still people are attempting the poll. Yeah, let me end it. I'm just sharing the results. I'm stopping it. Thank you. Thank you for your input. It's interesting to see that everyone plans to deploy AI workloads in different environments. It's a good mix that some of the people want to deploy it on Cloud Run, GKE, on-prem. That's great. Whether you choose to deploy on anywhere, the good news is that Vertex AI integrates seamlessly with these environments, giving you a full flexible and robust management tools. Let's dive deeper into exactly how Vertex AI can help it, and also see how we can overcome some obstacles and do make a best practices. Now we have covered how we have built and deployed the RAG application, but in the real world, AI projects eventually place a lot of hurdles. So let's explore some of the best practices to overcome those obstacles in our real world problems. One of the main problem which we can think of is a prompt engineering. Clear instructions are key for reducing hallucinations. That is when a LLM fabricates information. If you explicitly specify context, style, or constraint to your prompts, you guide the model towards more accurate on-target answers. Tools like Spring AI can help or maintain and reuse prompt templates, ensuring a standardized approach. The next thing is security and data governance. Encrypting data and controlling how LLM is used is crucial for enterprise settings. If you are passing a sensitive data to the model, we need to use some secure endpoints and consider data masking when storing logs. Additionally, we need to implement some access control mechanisms. So only authorized services can call AI apps or AI APIs. This is especially important when dealing with user-specific or proprietary information. Always keep, the next thing is monitoring and logging. Always keep eye on usage and pattern and performance. This helps you to detect anomalies, see if the model accuracy start drifting, and quickly identify the bottlenecks. You see Spring AI built-in logging alongside with cloud monitoring, like GCP cloud monitoring. Over the time, these metrics can inform you to refine your prompts and come up with retrieval strategies. The next one is cost optimization. When it comes to the cost, AI can get expensively fast, especially if you are using GPUs or high-end compute resources. We need to have right sizing our resources, whether in Vertex AI or any other cloud. Auto scaling, off-peak scheduling, or using CPU-based deployment for our lower volume workloads. And other is connecting to our MCPs. MCP provides a standardized protocol for clearly defining our AI models interact to different data sources or services across the infrastructure. Following these best practices from a well-crafted prompt to carefully resource management, we will help keep your RAG applications accurate, secure, and cost efficient. In our final slides, we will recap key takeaways and open the floor for your questions. Now let's quickly revisit where we have started 1 hour back. Not too long ago, Java developers faced a fragmented AI landscape. AI integrations was heavily on Python-dominated or Python-centric, leaving Java teams to piece together solutions that often feel disconnected, challenging to scale, and remain difficult to maintain. Before solutions like Spring AI comes along, it's common to build a separate Python services or rely on limited Java libraries, leading to duplicate efforts and trick crossing language integrations. This left many Java teams feeling unconcerned and uncertain adopting AI to an enterprise scale. Today, we have introduced Spring AI, an innovative project that does AI what Spring Boot did for web application and microservice development, offering a Java developers a familiar, standardized, and streamlined approach for AI integration. Spring AI empowers you to powerfully generate or build a generative AI applications directly within a Java ecosystem, significantly reducing the complexity which is around traditional AI. Spring AI enhances a capability further by seamlessly integrating with two critical components. One is Retrieval-Augmented Generation, where Spring AI leverages the ground large language models with real-time relevant data, ensuring response keep accurate and context-specific. The other one is MCP, Model Context Protocol, providing a standardized connections to diverse data sources, tools, and environments, making the integrations consistent, secure, and easily. With Spring AI at the center, the outcome is clear. Now we have a powerful framework to build an enterprise-ready AI application that are reliable, context-aware, and straightforward to manage. RAG integration ensures your AI responses stay accurate, fresh, closely aligned to your data. And deploying these applications, and we can deploy these applications whether on-prem, whether on containerization via GKE or Kubernetes, or on Vertex AI, which we can make it simpler. And Spring AI ensures every step remains coherent, secure, and maintainable, reducing complexity and helping your teams deliver AI confident rapidly. Ultimately, the greatest benefit in enabling Java teams to confidently embrace AI development without feeling forced into an unfamiliar territory. With Spring AI, you leverage the familiarity of Spring ecosystem to build robust, maintainable, and scalable AI applications, fully integrated with advanced AI approaches like RAG, standardized through MCP, and easily deployable in infrastructure platforms such as Google Cloud, Vertex AI. As we move forward, consider exploring these key components further through the lens of Spring AI. Experiment with Spring AI and RAG to provide more accurate, context-rich AI experience. Leverage MCP within Spring AI apps to standardize and secure data to different integrations. Explore deployment on platforms like Vertex AI to scale your Spring AI-powered solutions effectively. By taking these steps, you build AI-driven application that your organization can depend on, scale with confidence, and manage effectively. We have journeyed from fragmented AI integration to a cohesive Java native solution powered by Spring AI, enhanced by RAG and MCP. I appreciate your time today and would love to open for questions and deep discussions on Spring AI, which can help you. Thank you.
Thank you, Karthik. Thank you, Karthik. We have one question in the chat by Prakash. What is the reason of choosing GCP, not AWS?
Yeah, we can choose AWS also. Yeah, it's not something. Yeah.
Does MCP? Sorry? Yeah, sorry. Please go ahead, Karthik.
Yeah, sorry. So we can use AWS also. So I've choose GCP because I am more familiar with GCP. Okay. Yeah.
Thank you. We have one more question from Indranil Roy. Does MCP have any role during data ingestion? Can you please explain the content extraction part in short once more? Does the result of content extraction, which is prompt in this case, add to better response generation through LLM? You
Yeah.
can
So
check.
yeah. Wait, can you? Okay. Yeah.
It's in the Q&A. Yeah.
It's in the Q&A. Does MCP? Yeah. So MCP can be a part of data ingestion. So if you want to get the information from different sources, the MCP plays a crucial part. Okay. Coming to the content extraction part, so we will get the data from vector DB, which is embedded, which is more relevant to our user query. Okay. And in the context extraction, there can be some overlap of data from the different sources. Here we have vector database as one of the source. The other source can be MCP server. So we need to make sure that the content which we are passing to the LLM is refined. Okay. So that is the reason the main part of the context extraction is simple, to make sure that we provide a relevant data to the LLM so that we get a perfect output.
Thank you, Karthik. Indranil, you can unmute yourself. I hope Karthik has answered your question. Otherwise, you can.
Yeah, Karthik has answered my question. So I just had a confusion regarding the content extraction part versus like what we get as an output from LLM. So basically, we are building the prompt. Karthik, correct me if I'm wrong. So we are building the prompt using our content extraction service,
Correct.
and then we are
Correct.
feeding the prompt to the LLM, right?
Correct. Yes. Right.
So
Right.
it's like a cutout prompt that will be handled by LLM, so that we get a good response out of it. Am I thinking
Correct.
it right?
Correct. You are.
Cool. Okay. Thanks a lot, Karthik. Thanks, Rohit, for providing the opportunity.
Thank you, Indranil. We have one more question by Saurabh. Can we create AI agents and workflows using Spring AI?
Yeah, we can do that one. So that is the reason we have this session. So to know that, like, we can also do with Spring AI. Yes.
Ankit, today LLM are trained with older docs. How can we add web scraping content online docs for reference to LLM to refer and provide better response with updated code?
Yeah, that is where like RAG architecture comes in. So the architecture which I provided, right, that will give the updated responses or updated information to the LLM to get the output.
Ankit, I hope that answers your question. Okay. We have one more question from Yagnesh. How can we train enterprise data if you want to integrate into our enterprise applications?
Can be trained if you want to integrate into it. So I'm not clear about the question, but to answer you, we need to make sure that enterprise data is also clean so that we can use it. Yeah, we can use it for the RAG application. So it's not that we can directly get the enterprise data which is in a raw format or on an existing framework. So we need to do some data engineering work so that we can feed into a context extraction or making sure that we get a proper output. Hope that answered your question.
Yeah. Yagnesh, does that answer your question? I have given permission to unmute yourself.
Yes.
Thank you. We have one more from Adish. Shall we use Mutex instead of Vertex?
So here, Vertex AI is not a race condition. So Vertex AI is a service provided by GCP for hosting our like models. Okay, so you can search about Vertex AI. Okay, so it's not a like graph technique or something. Yeah.
I hope that answers your question. We have Shravan who has raised his hand for a question. Shravan, you can talk right now.
Thank you. I find this session interesting. Are there any more such sessions going to happen on agentic or any predictive stuff? I've seen some of the PDFs existing on your page, Grid Dynamics. I find that content also interesting. I'd like to get subscribed if there are any more upcoming sessions of this kind. Thanks.
Sure, we'll keep sending you. We have dynamic talks scheduled every month on different topics on different technologies. We'll keep you posted over email. You can also follow our LinkedIn page where we post everything that we planned for the next quarter.
Thank you.
Thank you, Sean. Karthik, we have one more question. Thank you for the sessions, says Vamsi. Thank you, Vamsi. How can we scale AI app?
Yeah, so there comes LLM ops or AI ops comes in. So that's a interesting topic again, how we can scale AI apps ops. So it's again a very big topic, so that we can see in future, like we can get those sessions coming up. There we can discuss like how we can scale AI apps, and that's very like interesting question. So now I can't answer deeply, but yeah, it's again a big question how we can do that one. So to answer you, the simple thing is we can use hyperscalers to make sure that we can scale it, and mainly focusing on our business logic.
Thank you, Karthik. We have one more question from Anubhav. How RAG differs from MCP, as they both are referring to external data source? Which one is better, or they should go together?
Yeah, I prefer, Anubhav, that's a great question. So we can think of a RAG as an approach or a framework rather than a parallel approach to MCP. So RAG can have multiple steps, as I discussed. One is like extracting the data and putting it into a vector database in the embedding form. The other step is like getting the data from different sources to the MCP. So to answer your question, the better one is we can go together based upon our use case.
Anubhav, I hope that answers your question. Okay. We have a question from Yagnesh. Thank you, Karthik. It was informative. Please plan a practical session in future if possible.
Sure, yeah, we will try to show the practical implementation of the app what we have developed. We'll try to do that one.
Like a suggestion, yeah. Thank you, Agnesh. Indranil Roy, again, one more thank you for you. Thanks once again. Would like to attend more such sessions on this, a bit more deep dive maybe.
Yeah, sure, yeah.
One question from Prakash. Are we planning to conduct any hands-on session in the future that might help us? I hope we answered that. RAG application with Spring AI from the scratch.
Yeah, we will do that one.
Any more questions, audience? I think we have helpful session. Would like to thank you, Saurabh. Perfect. Thank you, Karthik, for that insightful presentation. Your expertise has truly shed light on building enterprise-ready apps through Spring AI. And I'm confident by looking at all the questions from our audience, they'll carry these ideas forward in their own work. Before we conclude today's session, I'd like to take a moment to reflect on why events like Dynamic Talks matters. At Grid Dynamics, we believe in empowering the tech community by sharing knowledge, fostering innovation, and building connections. Your participation today, whether as an attendee, a speaker, or a collaborator, helps strengthen this ecosystem. For those of you who are inspired by today's session, we invite you to explore how you can be part of our journey. Whether you're a seasoned professional or a curious learner, Grid Dynamics offers opportunities to working on cutting-edge technologies, grow your skills, and shape the future of technology. Please visit our career site or our LinkedIn page to learn more. Also, please stay tuned for more interesting dynamic talks in the coming months, where we'll continue to explore transformative topics and host industry leaders. Please follow us on LinkedIn to stay updated. We'd also love to hear your feedback. Please take a moment to fill in our feedback form, which will be shared post the webinar. Finally, thank you all of you for joining us today. Your engagement and your questions and your appreciation made these conversations meaningful. Until next time, keep innovating, keep learning, and keep pushing boundaries. This concludes today's Dynamic Talks. Have a fantastic day, everyone. Good evening.